word of prayer. You can raise your hand. Yes, Melissa.
Let us pray. Father, King of Glory, we thank you for bringing us here. May we understand everything from this room lesson, oh God, Father. And where we have not understood, may we ask our teacher. Bless our teacher and bless us all. In Jesus' name I have prayed. Amen.
Amen. Thank you so much, Melissa.
Welcome.
Once again, I want to welcome all of us to this lesson. And I'll request that we restrict the chat to information that is related to the lesson so that we can all learn together. So our congratulations upon reaching Senior 2, and today afternoon we'll be looking at our first topic in Senior 2. And who has a clue on what that topic is? Yes, Laura?
The activity series.
The activity series. Okay, thank you. That's a good try. Yes, Adolo, sorry.
Okay, the first topic is acids, bases, and salts.
Okay, thank you. That is good. So we'll be looking at acids, bases, and then salts is another topic that comes after acids and bases. Okay, so Nora, do you still have something to say, or you just forgot your hand up? Okay. So we'll be looking at acids and alkalis as our first topic in Senior 2, and it's one of the most interesting topics. Someone is saying in the chat they can't hear me. Is that true for everyone?
We can hear you.
Okay, thank you. Maybe if you're not hearing me, you can log off and then log back. Eh? Okay, so we have some keywords, and I'm going to request someone to raise their hand and they read for us these keywords. Anyone? Adolf, it's good, but let me get someone else as well. Eh? I love your activeness. Keep it up. Please, can we have someone else read for us these keywords? At least they are simple, so anyone can really read. Yes, Bernard.
Acids, acids, alkalis, bases, neutralization, pH, proton reaction, and precipitate, and lime water.
Okay, that is good. Thank you so much, Bernard. So these keywords, we are going to keep interacting with them, and every now and then I'll keep asking us what we think those words mean as we get to those points. So for now, you just need to have them at the back of your mind that those are some of the words we are going to interact with. Acids, alkalis, bases, neutralization, pH, proton, reaction, precipitate, and then lime water. And then we also have the competence, which we are expected to know. Sorry, the learning outcomes, which I know we are all conversant with by now. So I'll request someone still to raise their hand and they read for us. Yes, let's have Annabelle read for us the first one.
By the end of this chapter, you should be able to recognize that locally available materials and substances are either acidic or alkaline. Understand the concept of pH as a measure of the strength of acids and alkalis, and understand the reaction between acids and alkalis.
Okay, very good. So As we go about the lesson, these three should keep rhyming in your ears. Actually, if you have somewhere to write, you can, sorry, no writing will take a lot of time. You can just screenshot them. Then when we are done with the lesson, you can have somewhere to write them. Because as we go over the lesson, these are some of the things that should keep ringing in your mind. That have I recognized that locally available materials and substances are either acidic or alkaline, sorry. And then can I be able to understand the concept of pH as a measure of the strength of acids and alkalis? And then can I understand the reaction between acids and alkalis? So for today, our lesson will really center on the first learning outcome, which is recognizing that locally available materials and substances are either acidic or alkaline. Okay, so have we taken the screenshot?
We are done.
Okay, thank you for that feedback. So we also have what we call the competence, and the competence sums up everything that we're supposed to look at. So I'll request someone to read for us this competence.
We should be
Yes, good
able to
luck.
appreciate the properties and importance of the acids based on the life.
Okay, let's have Mary.
You should be able to appreciate the properties and importance of acids, bases, and salts in everyday life.
Very good, thank you. So as I said on the learning outcome, still the competence sums up everything you're supposed to look at. So you should be able to appreciate the properties, importance of acids, bases, and salts in our everyday life. Oh, Hannah is saying some of them are writing. Okay, I think we'll share some of the bits on the group. Even when they share the YouTube video, you can always click and rewatch that part so that you can have enough time to take down notes. Okay, then the people that are not hearing me, please kindly can someone maybe post in the chat that maybe they can log out and then re-log in case they are not hearing me? Thank you. Okay, so we have a picture here. It's not very clear because of the resolution, but at least it is bringing out something. I will read the words. So we have household acid and bases, and we have examples of common acids and bases at home. And we have vinegar, we have lemon juice, we have battery acid, we have soda. Are there some other acids that we know that we interact with at home? You can post your answer in the chat, or you can raise your hand and you tell us. Okay, someone is saying Jig, thank you, that is good. Even it's hot 10, can you please mute your mic? Okay, those who are willing to answer, please you raise your hand and when we choose you can unmute and say something. Magic, okay. Any other? Adlock? Am I
Raw
really
mangoes.
pronouncing your name right?
Yes.
Okay.
There is raw mangoes.
Raw mangoes, good. Any other? Lemons, good. I'm seeing liquid soap, liquid soap. Is liquid soap a base or an acid? Okay, maybe as we go about, we'll see, but it's a base, as Austin has said. Okay, live. Any other? Okay, so as we go about the lesson, we are going to discover more and more of the acids that we actually have, and even some that we didn't know that were acids, but those things actually contain acids in them. And then, of course, I have some examples here for bases or alkalis. We have baking soda, we have ammonia, we have soap, we have borax. Any others that we know that we interact with at home that are not mentioned here, but they are bases. Or more? Good. Any other? Adler?
There is banana peelings.
Banana peelings, very good. Any other?
Blood.
Ariel, I didn't hear what you say.
Blood.
Blood. Then Mary's talking about definition. We've not yet talked about the definition of an acid and a base. We've not yet reached there, but that's where we are going. So just keep listening in. Okay, we have toothpaste, very good. Then we have Omo, good. Any other? Okay, those are all beautiful answers, and as we navigate through, we'll discover more of those examples. So I'm going to request us to look at the following, and you can put in the chat or raise your hand and you tell us if you tested these things. What was their test? Was it sour? Was it bitter? How was it? And then we'll get from there. Is it a base? Is it an acid? Because of the way it will have tasted. Okay, so we start with raw mangoes. Those that have tasted raw mangoes, how do they taste? Are they sour? Are they bitter? Are they slippery? How is their taste? Okay, I'm seeing the answers in the chat.
Shower.
Bitter, sour, and I'm seeing some hands. Yes, John?
Bitter.
Bitter, okay. And then, good luck.
They were sour.
They were sour, okay. How many of us have tasted alvera, the chigaji thing? How does it taste? Is it bitter or sour?
Sour.
I'm going to have to ask some of us to check in the dictionary what sour and bitter mean. Okay, Melissa, what was the taste like? Is it bitter or sour?
Bitter.
Okay, then John. Okay, so I'm seeing, sorry? Okay, I'm seeing the answers dominating the chat are bitter. So you realize that there is a difference between bitter and sour. So when you look at the raw mangoes are sour, and yet alvera is bitter. So for us who have tasted both of those, you can relate that the taste is different. Something that is sour, there is that sharp taste in it. And then bitter, of course, there is a way you feel on your tongue. Okay. So for mangoes, we say they are sour. Please keep noting down for the different items that we'll list here and how they taste, so that when we make the conclusions, you're able to have a wide scope. Then how many of us have tasted okra? What is the taste? Is it bitter or sour? Ada?
I think it's more of slippery, like doesn't have that sour taste or bitter taste.
Okay, that is good. But we understand that it has that slippery bit of it. Good. Okay, let's hear from Mary.
I also say that it's slippery.
Okay, that is good. Abraham.
It's slippery and somehow bitter.
Okay. Sulfur, is it sulfur? Sorry if I'm pronouncing your name wrongly.
Okra is slippery, and I don't think okra is either sour or bitter because it's a little bit tasteless, like water.
Okay, that's true. So you realize that okra has that slippery component, but we can't really qualify it as sour or bitter. Okay, that is good. Thank you for your contributions. And then we move to the next. I hope we are noting down some of those things. Eggplant, those of us that have tested eggplants. What is their taste? Please, those who haven't tested okra, you should really try it out. It's beneficial for your health. Okay, let's hear from Infinix Hot 10. But maybe you should also label your name. Eh?
Yes.
It's sour.
It's sour. Okay. Any other?
It is sour.
It is sour. Joanne?
I have a question. Are the eggplants you're asking cooked or raw?
It can be either. You can specify for us. Is it the raw or the cooked? And then you tell us what taste they have, because I am sure the taste should be almost similar. Okay, let's hear from Wandera. Sorry? Wandera, I don't know if it's me who is not hearing you, but I can't hear anything from your end. Okay, let's hear from Good Luck.
What did I forget now?
Like when the eggplants are raw, they're a bit like somehow tasteless, and then like when you eat it, it's a bit like sour, somehow sour.
Okay. How many of us know what eggplants are? Because we may be saying these things and some people don't know how they look like. Okay, let me briefly check out for the images. But you realize that eggplants are slippery and they have that bitter taste. It's not really as strong as the one for alveoli, but at least there is that bitter taste in them. And then lemons. Someone will remind me before we close that I can show us the images of okra and eggplant, because some people kept asking in the chat what they look like. Sorry, what about lemons? What happens? Are they sour?
Lemons
okay. Lemons are?
Bitter.
Okay.
Sorry.
I think the taste lemons have is sour taste, really, if you compare them with raw mangoes. Though sometimes the ones that we eat are genetically modified. They don't have really that original taste, but at least you can see that you can taste the sourness in them. Okay, thank you for your contributions in the chat. Let's move on to the next one. Tomatoes. Yes, Bernice. Is Bernice there? Okay, let's hear from Mary.
It is sweet.
Okay. Let's hear from Help. Help, can you unmute? Okay, Adlo.
It is sour.
It is sour. Okay. Some are saying bittersweet, others sweet, others raw ones are sour. Okay, so tomatoes have that kind of sour taste, and at least what we know, they are not what? Slippery. So that is something we need to. But the ripe ones, of course, may not be as sour, but the bit of raw ones are sour, and at least they're going to direct us according to what our topic is showing us. Okay, and then we move on to, according to the tests of these different things that we've mentioned here, including alveoli, which I didn't outline, what would you say about acids and alkalis in relation to what we've just discussed? Sour, bitter, slippery, and all those things. How can you relate them to what you can say about acids and alkalis? Yes, Mary? Petrina?
I think that most acids are sour. They have a sour or a bitter taste, and then most alkalis are just having a slippery taste.
Okay, thank you. Good trial. Though we can improve that. Safra?
I think acids and alkalines determine the taste of something.
Very good. Adlo?
I think all substances containing acids are sour, while those containing alkalis are bitter.
Okay, that is good. Angel? Angel, you had the same thing because your hand quickly went down. Okay, so students, I want us to notice something, that when we're looking at raw mangoes, when we're looking at lemons and tomatoes, we kept saying these things are what? Are sour. So when you look at lemons, who can tell us what acid is found in lemons? Because at least that one, everyone at least should have a clue on what acid we find in lemons. Ariel?
Citrus acid. Citric acid.
Okay, citric acid, very good. So you realize that the lemons, the fact that you can identify that they have citric acid, that means they have the acidic kind of what? Of taste. But these acids are important in our daily life. Like we looked at the competence, it's going to help us find out what are the importances of acids and alkalis in our daily life. So you notice that when we looked at mangoes, we say they have a sour taste. When we looked at lemons, we say they have a sour taste. And tomatoes, when they are raw, we say they also have that sour taste, which also directs us that actually these fruits contain what? Acids because of their taste. So because of that sourness, we qualify acids to have that sour kind of taste. And then when you look at okra, we said okra may be tasteless, but it has that slippery component. Most of us have touched soap. When you touch soap, you notice that there is that slipperiness, liquid soap.
Teacher, we can't
They
hear
also
you.
have. Okay, sorry about that. I was saying, can you now get me?
Yes.
Yes.
So when we are looking at the alkalis, you realize that they have that slipperiness. And if we have, it's because I'm not expecting someone to go and test soap, but when you look at some of these other plants that you may test, maybe eggplant or banana peelings, maybe ash from banana peelings, you notice that there is that bitter kind of taste. Alveoli, you notice that there is that bitter kind of taste. So we qualify those things to be what? Alkalis, because they are slippery and bitter. So when you're looking at bitter and slippery, those ones qualify to become alkalis. And those ones which are sour, because of their taste, they help us to understand that actually those are acids. So I'm going to task us, go to your dictionaries even after this lesson and find out what is the difference between something being bitter and something being sour. So at least you're able to differentiate that too. Yes, sulfur.
Teacher, you say that when things are sour, they contain acid, and when they are slippery, they contain alkaline. But teacher, liquid soap, when you're making liquid soap liquid soap is slippery, but when they are making liquid soap, they put an acid. Why doesn't it qualify to be an acid?
Okay, someone who can help Safra to answer that question. Anyone who has an idea? Yes, Joanne. Okay, good luck.
Depending to on how I understand it, they might apply acid, but due to maybe the other ingredients mixed with it, it produces a different substance.
Okay, that is very good. Thank you. Melissa?
I think that the acid might take a less percentage than its slipperiness. That's why it's not considered an acid.
Okay, thank you. That is a good one. Adlo? Your microphone is muted. We can't hear you.
Okay, I think the acid which they use when making liquid soap may react with other substances which are alkaline. So maybe they end up forming an alkali.
Okay, that is a very good explanation. Annabelle?
I feel like when they put an acid there, like the level of the acid compared to the other components in the liquid soap make it to be an alkaline. Like when you compare the components that make it slippery and then the components that make it an acid, those that make it slippery are a bit more than the ones that are like acids.
Okay, that is very good. So, thank you. And I think now, Safra, you have at least an overview on what that meant. Because remember, when you're making liquid soap, there are very many components that you're using, and you're using acidic components and then alkaline components. So you find that the measurements used to make those different components, you find that when these other components react, maybe their alkaline nature surpasses the acidic nature, and the liquid soap is able to take on that format over of an alkaline substance. Okay, thank you all for your contributions. Have we answered your question, Safra?
Yes, thank you.
Okay, thank you. Okay, so we are going to move on. And this one, you will take out time to really go ahead and select some of those things, but we can quickly do an overview on what we can qualify them to be. But really, I will expect you to fill this table for yourself. Then sour milk, Of course, this one is already telling us. Does it taste sour, bitter, feel slippery? And what is it, an acid or an alkali? Let's quickly go through this table. Anyone who has a clue? Sour milk, where does it fall in this table? And is it an acid or an alkali? Yes, good luck.
It tastes sour and it's not bitter. It's not slippery and it's an acid.
Okay, that is very good. So you just go ahead and tick taste sour, and then you write in the last column that it's an acid. Okay, good. And then tomatoes. Yes, Ado.
Tomatoes taste sour and they are not bitter. They don't feel slippery and they are alkalis.
Sour, and then you say they are alkalis.
They are
Sour,
acids.
then yes, very good. And then soap. Okay, that is good. I can see someone helping us do some interesting work there. Soap, we said soap is? So we said soap is? Yes, Austin?
I have a question.
Mm-hmm.
I've ever tasted sour milk, but it's not that sour. But you're saying it's sour here. It's just fine.
Tastes vary from one person to another, but sour milk that has gone bad actually has a sour kind of taste. I don't know, but it actually has that sour kind of taste. That's why they call it sour milk, because it has gone bad. And someone may find bongo okay, but me personally, I am not very okay with bongo. So you can see that there is variation in taste, but it doesn't deny the fact that it has that original taste that some of us don't actually take note of. Austin, is that okay?
Yes, it's okay.
Yeah. But thank you, that was a good one. Josiah, we said when you're looking at acids, we said for them, they have that sour taste. That's how we can look at them. And then when you're looking at alkalis are slippery, and then they also taste in a bitter way. So their taste is bitter. Okay, so please, Wandera, I don't know why you're ticking in the last column. The last column, we really said someone should be able to write the word. Is it acid or is it alkali? And like I said, this table is for you to fill for your own enlightenment purpose. But I just wanted us to go over some of the things that we had looked at the beginning. And please let's not defy the rights that have been given to us by keeping on writing here and there. It's not really okay. Okay, so you go ahead and complete that table. So we have some discussion questions that I want us to discuss here. So what is the general name for substances that have a sharp and sour taste? According to our discussion up there, what do you think those substances are called? Yes, Melissa.
Acids.
Acids, very good. Thank you. People in the chat, you're doing a great job. I like the fact that we are really using the chat well. Yes, so keep it up. Okay, So they are called acids. Then those substances, what is the general name for those substances that are bitter and slippery? Good luck.
Alkalis. Alkali.
Yes, alkalis or alkalis. Okay, alkalis. So those that are bitter and slippery, we call them alkalis. And of course, you can go ahead and look at more examples within your home and find out what are those substances that we have at home that can actually be this. So what acids do we find in different substances? You can mention the substance and you tell us what acid is found there. In that substance you're telling us. So you tell us the substance and then the acid. Yes, Mary.
In oranges, you find citric acid.
Sorry?
In oranges, we find citric acid.
Okay, good. And then I've seen someone saying amino acids in proteins. That is good. And in the chat, I'm seeing lemons have citric acid. That is good. Those are all good answers. Yes, Mary, you've just given, right? Yes, Adbo.
The substance is urine and the acid is uric acid.
Okay, good. And then someone is saying folic acids in tomatoes. Good. Any other? Mary, you still have another answer?
No.
Okay. Raj?
Oxalic acid in tomatoes. And
Okay.
also, if you don't mind, even tartaric acid in grapes.
Okay, that is very good. Nora?
Lactic acid in sour milk.
Okay, that is good. Okay, so those are all beautiful answers. Thank you. So I'm going to get someone to read for us this statement here, because these are some of the acids that we find in our daily life. Of course, there are many like you've mentioned, but we still have some of those. Yes, help. Okay, let's have Raj read for us.
Yes. So methanoic acids in bee and ant stings, citric acid in raw mangoes and lemons, lactic acid in sour milk, carbonic acid in rainwater, ethanoic acid in vinegar, amino acids in proteins, vitamin C, or ascorbic acid in fruits.
Okay, very good. Thank you. So we have methanoic acid, and as we go about, we'll see that when a bee or an ant stings you, what strategy can you use as a chemist? Instead of shouting and saying you don't know what to do, what can you strategize that since this sting and this ant sting contain an acid, what am I going to do for this person? So as we go ahead, that question should ring in your mind. As a chemist, what would you do? Would you just scream and call your mom and scatter everything, or you would do something about it? And then we also have citric acid in mangoes and in raw mangoes and oranges. Then of course, lactic acid in sour milk, carbonic acid in rainwater. Of course, I am sure you looked at some of the pollutants and maybe you interacted with the ones that affect the rainwater when you are looking at air and rainwater in senior one. And then we also have ethanoic acid in vinegar. So you'll find that sometimes vinegar would be called ethanoic acid. So it is something that you interact with. And then proteins, we have amino acids and then ascorbic acid in most of the fruits. So you realize that we have those things in our daily lives. Okay, someone is saying hydrochloric acid in the stomachs of living organisms. Okay, that is good. Those organisms that have a digestive system. Okay. You guys are all brilliant. I like this class surely. Okay, how can we know that a substance is an acid or an alkali? Who can tell us according to what we've looked at? How can you just know? Yes, Melissa.
We can know by its taste and nature.
Okay,
For the
very good.
alkaline.
Okay, good. Help, I don't know. You put up your hand, but when we called you to say the answer, you never unmute. I don't know if it's just something you do by interest.
Acids have a sharp and sour taste, while alkalis are bitter and slippery.
Okay, good. And then, of course, as we go ahead, because I don't expect someone to go to the lab and start testing hydrochloric acid, saying, I need to know if the taste is sharp, if the taste is sour. So as we go on, we are going to find out what are some of the other ways we can use to determine if a substance is acidic or alkaline. So that we don't find in the lab testing different chemicals and saying, Chamata told us, so we are now back to school, let's test these things. So it's important that you realize that the things we've been using to test these tests are things that we can eat or things that we can touch, and they have no effect on our bodies. Okay, so Mary, your hand is up. Do you have a question or an answer?
Teacher, I have an answer of knowing how a substance is acidic or alkaline by use of litmus paper.
Okay, that is good. Though you're taking us at a very high speed. Yes, Annabelle?
Teacher, I have a question. I've
Yes,
heard
please.
people say something about acid being corrosive. What does the word corrosive mean?
Anyone to tell us what the word corrosive means? Good luck.
Corrosive means like take for example, if it is dropped on a metal, it can create a hole, like something of the sort, can even harm a human body.
Okay, that's a good trial. Thank you. Mary?
Corrosive is a substance that is capable of destroying solid materials, tending to eat away or consume something.
Okay, that is good. So when you're looking at corrosive, something being corrosive, for example, when you look at some metals rust while others can corrode, or substances can corrode. Raj, do you have something to say?
Yes, ma'am. Corrosive, another meaning, okay, its main definition is it means that corrosion, it's a natural process that converts a refined metal into a more chemically, hello? Yeah.
Yes, we are hearing you.
Into a more chemically stable oxide.
Okay, that is quite deep for now. Thank you, though. So when you're looking at corroding, something either loses its color, its texture, or its original state. So it is different from rusting, but it loses its original state. So if maybe a metal has corroded, for example, if it had a specific kind of painting and it got exposed to an acid, you realize that there is the coloring that was there initially is washed away to create another kind of surface. So that is basically, in simple terms, how I can say corrosion really is. I don't know if I've answered your question, Annabelle, or everyone has helped answer your question, because at least we kept getting a few inputs here and there. Okay, so now we come to an acid, what an acid is. Okay, so may I have someone to read this for us? Someone who hasn't said anything, please put up your hand and read for us. Yes, Karos.
An
acid is a substance which, when dissolved in water, produces hydrogen ions as the only positively charged ion.
Okay, very good. So we've understood the other bit of acids a bit, have a sharp taste, they are sour. But now when we come to the chemical composition of what an acid is, like we are going to see in the lab when we go back to school, you realize that why we call something an acid, it's because when we dissolve that substance in water, it produces hydrogen ions as the only positively charged ions. I know we have not yet looked at some of these things, so I'll just use hydrochloric acid, which all of us know, because at least you have it in your digestive system. So when we have hydrochloric acid, for example, yes, Austin, your hand is up.
Madam,
yes,
what's the meaning of ions? Like, I had it in primary, but I don't know its meaning. I just here read.
Oh.
So, I wanted the meaning.
Hydrogen. Okay, let me come just briefly. Let me just write this equation here. Plus chloride ions. Okay, so that is an interesting question. So when we are talking about ions, the same way you have positive and negative in math is the same way we have charged particles in what? Charged particles in chemistry. So when we have what we call charged particles, those charged particles are either positive or negative. So if they are positive or negative, if they are positive ions, we call them, well, let me share a whiteboard for now. When we have those positive ions, those ones become what? Cations. And when we have the negative ions, those become the what? The anions. I call them anions, but I keep hearing my students call them anions. I don't know if it helps them on the spelling bit. So these positively charged ions happen if a substance is dissolved in water, or if we've lost or gained electrons, and that is a bit of high chemistry that I don't want to go into now. But when you're looking at ions, we call them charged particles. So those charged particles are either positive or negative. And those negative ions are called anions, while the positive ions are called cations. Austin, I don't know if I've helped to answer your question a little bit.
Yes, madam. Thank you.
Okay, thank you too for that feedback. So when we are looking at positive ions, we have said that an acid is a substance which, when dissolved in water, those words are important, it must be dissolved in water. So when it is dissolved in water, it will produce hydrogen ions as the only positively charged ions in that case. So I want us to really move together here, and if I'm fast, please let me know so that I can slow down. So for example, which other acids have we heard of? Yes, Mary, do you have a question?
Teacher, phone mine is a question. So when you say an acid is a substance which, when dissolved in water, produces hydrogen ions as the only positively charged ion, you mean like if you put a substance in water and then it produces another positively charged ion, it's not. So are you trying to say that hydrogen ions are the only positive ions that exist?
Not really, Mary. What happens is, what substance are you dissolving in water? Like even when we go to alkalis, we will introduce something. That's why I'm saying when you look at an acid, the component that makes an acid be called an acid is the fact that there is a hydrogen ion, which is positively what? Charged. And of course, when we dissolve these things in water, we expect that they are going to split and give us the positive ions and then the negative ions. And of course, we know that in chemistry, hydrogen ions are positively charged. But of course, when we get to the periodic table, we'll look at there is a difference there. But for now, I want you to understand that when you're giving off hydrogen ions, they are given off as positively charged ions. So what makes that acid to be called an acid is the fact that when I dissolve it in water, it's going to split to give me hydrogen ions as the only positively charged ions. For example, in the chat, I've seen someone talking about sulfuric acid. Sulfuric acid, when dissolved in water, will also give us what? Hydrogen ions as the only positively charged ions. Then when we look at nitric acid, still it's going to do the same thing. When we look at citric acid, but of course, some of these acids, we don't use their formulas at this level. But when you find out their formulas, you notice that they have hydrogen ions, which when dissolved in water, are given off as the positively charged ions. Okay, so I want us to keep our focus here. I don't know if Mary, for now, I've answered your question because I want us to dive into something else for now.
Yes, teacher, you have.
Okay, thank you. So at that part, I want us to look at something here very quickly. I'm going to use the common acids, but of course, I'll not use the citric acids and then the rest, but I'll use some of the lab acids that we use at school. So that when we go back and our teachers are talking about some of these things, we are able to relate. So for example, we have hydrochloric acid. Please ensure that your equation is on one line. Don't break after, and then you just leave them the way they are. So we've said hydrochloric acid. Something you need to understand about hydrochloric acid. Allow me to use chemical symbols, but for now, don't write chemical symbol equations. Write word equations for now. When we learn the chemical symbols, then we can always write them. But for now, so that we have correct work, because some of us don't really know how to write these symbols. That's why I'm putting a disclaimer there. So for me, I'll use them because I want us to understand something. So when we are writing hydrochloric acid has hydrogen and it has a what? A chloride. So this is hydrogen and this is a chloride. Those two make up hydrochloric acid. So when we come this side, because we said acids produce hydrogen ions when dissolved in water. So that means hydrochloric acid will split, which we call ionize, into hydrogen ions plus chloride ions. So we have hydrochloric acid dissolving in water to give us hydrogen ions plus chloride ions. So since we've said it has that, that means we'll have hydrogen ions as the only positively charged ions plus the chloride ions. And since we said hydrogen ions as the only positively charged, what does the chloride become? A what? A negative. So that means we'll have hydrogen ions and then the chloride ions, which are negatively charged. Are we together on that example before I move on to the next example?
Yes.
Yes.
Okay, thank you.
Yes.
So now I'm going to use sulfuric acid. What two components make up sulfuric acid? Someone who has an idea? Yes, Adlo?
I think the components which make up sulfuric acid are sulfur and chlorine.
Sulfur and chlorine, okay. The sulfur is okay, but the chlorine, no. Thank you.
Excuse me, ma'am. Is it okay if I can tell you?
Yes, please.
Okay. Yeah. So sulfuric acid isn't made up of like two elements. It's made up of like 3 and 4. So these elements, they are known as sulfur, oxygen,
Okay.
and hydrogen.
Okay, that is very good. Thank you so much, Raj. So you realize that sulfuric acid is made up of 3 elements, and those elements are hydrogen, sulfur, and oxygen. So like I said, for now, please don't be taken away by these symbols, because I'm just using them to get a clear picture for us on how these things operate. So we say that when we are looking at these acids, because we know that an acid is identified by producing hydrogen ions as the only positively charged ion, therefore we'll have hydrogen ions, plus sulfate ions. So in this case, these are the hydrogen, and this is what we call a what? A sulfate. The S.O4 is what we call a what? A sulfate. And as you look at periodic table in the future parts of the year, you'll find out what a sulfate is and why we write it the way we write it. Your teacher will expound more on that. But for now, like I said, I am just using these symbols to explain better. So if we have hydrogen and then the sulfate, we said hydrogen ions are positively charged. That means we'll have the hydrogen ions plus the sulfate ions. And since the hydrogen ions are positively charged, that means the sulfate ions are negatively charged. And then that means here you have your what? Your acid, because it has produced hydrogen ions as the only positively charged ions. The other part is negatively charged. Have we also understood the sulfuric acid being an acid?
Yes.
Okay, thank you. Okay, so let's try out the one for ethanoic acid, which we said we find in vinegar. And maybe before we go to ethanoic acid, we can first look at nitric acid because it's also a common acid in the lab. So the common acid we have also is nitric acid. Please don't get confused and make sure we don't leave you, because these are important aspects that you need to know. So we've also said there is nitric acid. And nitric acid, we have nitric acid written as this. So you see it also has hydrogen on it. Hydrogen and then what we call a nitrate. A nitrate is a composition of nitrogen and then oxygen with a 3 on it. So we have hydrogen ions. And then plus the what? The nitrate ions. So that means here, this one will dissociate to give us hydrogen ions plus the nitrate ions, which are negatively charged since the hydrogens are already positively charged. So something you need to take note of, you notice that hydrochloric acid gave us hydrogen ions and then chloride ions. Sulfuric acid gave us hydrogen ions and then sulfate ions. Then when you come to nitric acid, it gives you hydrogen ions plus nitrate ions. But the highlight here is that they give off hydrogen as the only positively charged ion when dissolved in water. Okay, so nitric acid is found in the lab, and that's where you interact with some of those substances. Those people who are saying they're confused, can you unmute and you tell us where we can help? Because if you just put in the chat confused, and please always refuse to be confused. Confusion is not the best place to be as a student. Then Adolf.
Madam, I have an addition on nitric acid.
Yes, please.
Nitric acid also exists in nature when it is raining and there is lightning. So that lightning provides energy which oxidizes the nitrogen dioxide in rainwater, and they end up forming nitric acid.
Okay, that is good. Thank you so much, Adlo, for that. Please, the people who said they are not with us, can you please let us know where we can assist? Okay, I'll go through this one more time, starting from hydrochloric acid, where I started from. So please pay close attention. And I think some people went off track when they started posting some things in the chat. So let's just keep our eyes on the screen and really focus. I know this bit is a bit challenging, but we can always get there. So please let's pay close attention so that we work together. So hydrochloric acid, I said, did we all understand the definition that when we dissolve an acid in water, it produces hydrogen ions as the only positively charged ions? Okay, so if we understood that bit, I have said the first acids we interact with in the lab, the commonest, the first one we have is hydrochloric acid. So I said hydrochloric acid, when you're using the chemical symbols, you notice that hydrochloric acid has two elements, which is hydrogen and then a chloride, or what you can call chlorine if it is just an element. But when chlorine combines with another element, it becomes a chloride. So in this case, we have hydrogen and chlorine. And we've understood that when we are looking at an acid, it's going to give us hydrogen ions when dissolved in water. So we'll have those hydrogen ions plus the what? The chloride ions. So when we have those two, we have said, I am using these symbols just to help you understand what is inside that acid that causes it to produce hydrogen ions, and then the other part that is a negative ion. Like someone asked what are ions, and then I explained that these are charged particles that happen when dissociation happens. So in this case, hydrochloric acid is being broken down, if I'm to use the layman's language. But in chemistry, we would say dissociation or ionization because ions are being formed. So in this case, hydrochloric acid is breaking down into those different ions. And those different ions that it contains, of course, it can't produce something that it doesn't have. So that means if it has hydrogen on it, and then a chloride on it, if we produce hydrogen ions as the only positively charged ions, that means the chloride ions are the ones that are negatively charged. And that is why I wrote that here you will have hydrogen with a positive charge on it, plus chlorine with a negative charge on it. Because remember, we said an acid produces hydrogen ions as the only positively charged ions. Are we together up to that part?
Yes.
Yes.
Even those that we had left, are we together?
Yes.
Yes. Yeah.
Yes.
Okay, thank you. Bobby, your hand is up. Bobby? Okay, it went down. Okay, I think we can now continue. Thank you for that feedback. So after that, we'll have sulfuric acid. So when we are looking at sulfuric acid, we have sulfuric acid, which gives us hydrogen ions. That's a sulfate ions. Because here, when dissociation happens or when they break into ions, we expect that you're going to get a positive ion and a negative ion. So in this case, I saw someone saying I said there is sulfur. Yes, when you're looking at sulfuric acid, we have 3 elements in it. We have hydrogen, we have sulfur, and we have oxygen. But like I said, when you're looking at the periodic table, you look at something we call a radical, and this sulfate here falls under that category. So that is why I'm saying that we can't separate it and then we say sulfur and oxygen are becoming negative. This one goes as a whole thing. So that means in this case, you'll have hydrogen ions as the only positively charged ions. And I told you not to mind these formulas because they are just helping me help you understand better what is happening. So here you realize that when sulfuric acid dissolves in water, it's going to give us hydrogen ions, which are positively charged. And then if hydrogen ions are positively charged, that means the other part is negatively charged, and those are the sulfate ions. Are we together up to this part as well?
Yes.
Yes.
Okay, thank you for that feedback.
Should I beg your pardon?
On what?
How the sulfuric sulfate ions dissolve in water.
It's not that sulfate ions dissolving in water. It is the what? It is sulfuric acid. Like, for example, we'll go in the lab and dissolve sulfuric acid in what? In water. So when we dissolve the sulfuric acid in water, that means we are going to have, Ariana, please stop writing on the screen. So we have sulfuric acid. When it dissolves in water, since we've said an acid produces hydrogen ions as the only positively charged ions, then what is the remaining part going to be? The remaining part is what? Is a sulfate. That means the sulfate becomes negatively what? Charged. Are we together, Ariana?
Yes.
So have you now understood that part?
Yes, I have.
So that is basically what we look at when we are looking at those acids. Then we went on to nitric acid. So for nitric acid,
Excuse
we
me,
have
Tisha.
nitric acid.
Beg your
Yes,
pardon.
please.
Tisha, I beg your pardon on the sulfuric acid, I don't know, reacting with water.
Mary, you may have to go back and rewatch the video. Yeah? Let's kindly move a little.
Okay,
Is that
Tisha.
okay?
Yes, teacher.
Thank you. You just pay attention on this one for nitric acid, and then you'll go back and rewatch it.
Okay, teacher.
Yeah, thank you.
Thank you.
So when we have nitric acid, please, those people writing on the screen, don't misuse the rights that have been given to you, yeah? Because we don't want to restrict you and then we disable your writing on the screen. Eh? Let's behave. You'll explore, open your own Zoom and explore some of the features on Zoom. Eh? Okay, so when we have nitric acid, we said it dissolves in water to give us hydrogen ions as the only positively charged ions, plus the nitrate ions as the negative ions in this case. So you realize that nitric acid has hydrogen in it, and it also has the nitrate ions, which are made up of nitrogen, oxygen with a 3 on it. So that is why we call it nitrate. So you will go on and produce hydrogen ions as the positive ions, plus the nitrate ions as the negative ions. So one thing you have to understand here is you're producing hydrogen ions as the positive ions. Then the remaining part becomes negatively what? Negatively charged. Because in this case, hydrogens as the only positively charged ions. Someone is asking, how do we rewatch? Mr. Kaziba always posts the YouTube videos in your group, so you can always go back to your group and check for that YouTube video the day after the lesson has happened, and you can always find them. Yes, Raj, your hand is up.
Yes, ma'am. Actually, I also wanted to give some more information about nitric acid. Well, nitric acid, it's a corrosive mineral acid. Its compound, it is colorless, but samples tend to acquire a yellow cast over time. And the formula for nitric acid is HN, hydrogen, nitro, oxygen, and 3.
Okay, that is good. Thank you, Raj. Okay, so those information that people keep giving us, please keep noting them down because they may be really helpful. Thank you so much, Raj. That was good. So when we have nitric acid, it is also going to dissolve in water to give us hydrogen ions and then the nitrate ions. I don't want us to overthink these things. Just compose your mind and tell your mind that you can really understand these things. That if I produce hydrogen ions as positive ions, that means the other ions that remain within that substance should be negatively charged. That is one way I can really help us understand that. Are we now all together up to this point?
Yes.
Yes, ma'am.
Yes.
Yes.
Okay, thank you.
Okay.
And of course, the things we cover here, you can go back and read more about them so that you can understand them. It's very important for you to go back and read about them and understand them even better, because I believe there is always a better way of understanding some of those things. Okay, so I had said lastly, we are going to write the one for ethanoic acid, which we find in vinegar. Mary, can you please mute your mic because it has a lot of background noise that is really not healthy for us. Okay, so we said ethanoic acid. This one will give us, first of all, hydrogen ions. Plus ethanoate ions. So in this case, when we are looking at something unique about ethanoic acid, that's why I want all of us to have our focus here. Please, the co-host, can you help me mute those people who are unmuting their mics? Because you keep sending feedback, which disorganizes my explanation. Eh? Thank you. So when we have ethanoic acid, this is its formula. So one thing you need to discover about ethanoic acid, I am going to kind of change some techniques here. So please make sure your eyes are on the screen. And please refuse to be confused. Eh? So ethanoic acid, it's going to produce hydrogen ions as the only positively charged ions plus the ethanoate ions. Who can identify something unique about this equation and the equations we've been writing previously? Anyone who can tell us something they can see that is different from the equations we have been writing?
Okay. May I speak, ma'am?
Yes, please.
Okay, okay.
Yeah, okay. So what I think is that is different from the other equations that we gave are that the symbol of 3 in previous equations, any number symbol would come at the last, but here in this equation the symbol number, it's coming like at the third position.
Okay, that is good. Thank you, Raj. That's a good identification. Yes, Petrina.
What I'm saying is that it seems like this thing. I request permission to appear on the screen.
It's okay.
This, it means like if it is vice versa or something like, and the other equations haven't been having it, if I'm not mistaken.
Okay, that is a good one also. Thank you, Annabelle. So you notice that for the other previous equations, we've been using a full arrow. But in this case, we are using what? Half arrows. One facing this side, another one facing the other side. So that is a good one. Any other identification that we can see there? So she has told us this is also something to take note of. Yes, Mary? And then Raj told us this.
According to me, this H and this one. That's what I think.
Okay, thank you so much, Mary. That is also another good observation.
You're welcome.
Okay, so you notice that in the other equations, we've been having all the hydrogens being produced and they don't remain in the negative part. But when you look at this one, you realize that for it has remained with its 3 hydrogens here, and the 3 hydrogens are also existing this side. And the 3 hydrogens are also existing this side. And yet this last hydrogen has been given off as the only positively charged what? Ion. And yet we have other 3 hydrogens remaining within the molecule. So those are some of the things you need to take note of. You notice that in the other ones where we're having the full arrow, that was 1 arrow, we had all the hydrogens being produced. And yet here, some of the hydrogens remained within the what? The structure. Are we together?
Yes.
Okay, so I'm going to give us just 4 minutes to breathe a little, stretch your legs a little. So that means by 15:30, we should be able to proceed. So I just want you to stretch a bit, breathe in and out. And then we
Excuse
can
me, ma'am.
proceed. Yes, please.
How long will this meeting take?
It's ending at 4.
Okay, at 4. Okay, thank you.
Welcome. So please, at 30 minutes past 3, we are resuming again. Don't log off, just breathe a little, just as even those who are taking out some time to digest the things we've been discussing. Recording, can we please resume? Thank you. So we had stopped on defining an acid and we went through the different techniques on how we can illustrate how those acids produce hydrogen ions as the only positively charged ions. So I'll just read through this very fast. So we just need to follow through. These hydrogen ions released in aqueous solutions are the ones that make the substance acidic. That is very important for you to note, that the substances that release the hydrogen ions released are the ones that make the substance acidic. So that means for every acid, there must be production of hydrogen ions for it to qualify to be called an acid. And then, of course, we go to what an alkali is. Someone to read for us that definition. Yes, Ada.
An alkali is a substance that releases hydroxide ions as the only negative charged ion when dissolved in water.
Okay, thank you. So now, after understanding that acids produce hydrogen ions as the only positively charged ion, when we come to the alkalis, we are looking at when an alkali is dissolved in water, it will produce hydroxide ions as the only negatively charged ions. And in this case, I can give us an example. For example, sodium hydroxide is an alkali. So when we have sodium hydroxide, for example, let me share a whiteboard here. When we have sodium hydroxide, because remember we've said these ones produce the hydroxide ions as the only negatively charged ions. So that means if I have sodium hydroxide, when I dissolve it in water, it's going to split to form sodium ions plus hydroxide ions. Plus hydroxide ions. So these hydroxide ions here, for example, like I said, I'll still use the symbol equations just to illustrate something. So don't focus a lot on them, but just to help us explain. So sodium hydroxide is written like this. It has sodium, oxygen, and then OH. So the OH is what we call the hydroxide. So the hydroxide is made up of oxygen and hydrogen. But this hydroxide cannot exist on its own. That's why we need to combine it with another element so that it forms a hydroxide of that element that we've combined it with. So that is why we'll say sodium hydroxide. But you can never find a book or someone saying hydroxide and it's just alone. So it must exist with another element or compound in order for it to exist. So you'll have sodium hydroxide. This one can also be found in the lab. So you have sodium ions, which are positively charged, because in this case, we are looking at alkalis, of which alkalis produce hydroxide ions as the only negatively charged ions. So that means if the hydroxide ions are negatively charged, the other part becomes positively charged. So in that case, you'll have sodium ions plus the hydroxide ions, which are negatively charged. Then it takes us back to the definition that alkalis are substances which, when dissolved in water, produce hydroxide ions as the only negatively charged ions. Are we together to that point?
Yeah.
Yes.
Okay, thank you.
Yes, we are.
Then we also have potassium hydroxide, but this one I want someone to tell me what I'm supposed to do. Let me just rub off and then you tell me what to do. If I have potassium hydroxide and I dissolve it in water, which ions is it going to give me? Anyone? Yes, Safra?
When you dissolve potassium hydroxide in water, it will give you potassium ions and hydroxide ions. So
very good. Okay.
The potassium ions will be positive and the hydroxide ions will be negative.
Okay, that is very good. Thank you so much. So we have potassium hydroxide giving us potassium ions and then the hydroxide what? Ions. And in this case, that means I would have KOH. This is potassium, this is the hydroxide to give me potassium ions plus the hydroxide ions. Austin, your hand is up. Do you have a question?
Yes, madam.
Yes, please.
I have a question. Supposing I put the potassium hydroxide myself in water, how would I know that the hydroxide ions are positive or negative?
How will you know that?
Like if I do it myself, like I get this element, then I put it in water. How would I know that the hydroxide ions are positive or negative?
Okay, that is a very interesting question. One thing we are going to look at in this topic, we are going to be able to tell that this substance is acidic or this substance is what? Is alkaline. Like, for example, when we say a substance is alkaline in chemistry, we expect that this substance contains hydroxide what? Ions. And hydroxide ions are negatively charged. That is one thing you need to have at the back of your mind. Hydroxide ions are negatively charged. So that means if I am to test this substance, if it is alkaline, that means if it is dissolved in water, it cannot but give me hydroxide ions as the only negatively charged ions. Then if I am talking about an acid, because I have said what makes an acid is the fact that it has hydrogen ions. So hydrogen ions are always positively charged when dissolved in water. So that means that case, if they give you hydrogen ions, we expect that those hydrogen ions are not going to be negative, but they are going to be positive. Have I answered your question, Austin?
Yes, madam. Thank you.
Okay, thank you. Okay, so I can see there is a hand that is still up. Mary, do you have something to say?
No, teacher, I'm listening.
Okay, thank you. So we have also, we can look at, I have ammonium hydroxide. Still this one, I'm going to have someone to tell me what I'm supposed to do. Sorry, ammonium hydroxide. Someone to unmute and tell me what I'm going to write here.
Excuse me, teacher.
Yes, please.
I'll try you. I think you're going to write as ammonium ions plus hydrogen ions.
Very good. Plus which ions? Which
Plus
ions
hydrogen ions.
Okay, so
okay, I was like
here when we are looking at alkalis, we don't mention the word hydrogen anywhere. We said hydroxide ions. Is that clear? That means you are going to have ammonium ions plus hydroxide ions. So if we have ammonium hydroxide, it's going to give us ammonium ions plus hydroxide ions. So in that case, you remember also this time round, on the first two equations I've written, we had a 4 arrow, but when you look at this one, it has reversible arrows. So we have an arrow that produces the ammonium ions and hydroxide ions, and then another arrow facing the ammonium hydroxide ions. Of course, I'll task us to find out why those things are that way when we get to that point. But for now, you just need to understand that also, when you're looking at ammonium hydroxide, we have ammonium hydroxide here, which is dissociating to give us ammonium ions plus hydroxide ions.
Excuse me, ma'am.
Yes, please.
What I'm asking, apart from that, like I asked, I don't remember the person's name, but when he asked you a question, the question was that how can you differentiate which ions are positive and which ions are negative? I heard you say that answer, but okay, this is just a question. I'm not really sure about which answer you're going to give. Like, can we also differentiate which ions are positive and negative by the way that since ammonium, it's all the positive ions, like ammonium ions, they come at the first they come at the beginning, while the negative ions such as hydroxide ions, they come at the ending. So ammonium hydroxide.
Oh, okay. I don't know if I've gotten your question well, but let me try to answer. Then you can guide me on whether I have answered it as you've asked.
Yes.
So when you're looking at ammonium hydroxide, you're producing ammonium ions as the first bit, and then that may be a technique that you may use, but you also have to have a principle on how those things run. Like I said, of course, now the reason why I say don't put so much emphasis on this part, because you've not yet looked at these things. So they will a bit confuse you, but I want you to understand what actually happens. That's why I'm using them, but they don't need to take much of your attention. But when you get to the topic of periodic table, you will look at why we write these things the way we write them, and I don't want to go into the details for now. So when you understand that this one is positively charged, even when I choose and I say, for example, the positive bit is beginning here and then the negative bit is beginning here, you can use it, but you must have understood the principle behind why those things happen as positive charges and why they happen as negative charges.
Yes. Okay.
Okay.
Yes, ma'am. Thank you for answering.
Okay, thank you too. So are we all okay up to this point so that we can move on to the next thing?
Yes.
Yes.
All right, thank you. Okay, so we'll go back to our screen. So there is a beautiful question here. Who can tell us why we use toothpaste to brush our teeth? Who has a clue on why we use toothpaste to brush our teeth? Meanwhile, as we go on, someone can post the WhatsApp group link in the chat such that those people who are not on WhatsApp can join and they can get access to the video when it's posted. Yes, iPhone?
To stop smelling.
Okay, to stop smelling. That's good. Thank you. Anyone else?
Excuse me, ma'am.
Yes, please.
May I?
Mm-hmm.
Okay, so in toothpaste, there is a substance called fluoride, which strengthens the enamel of our teeth, therefore preventing tooth decay.
Okay, thank you. Elaine?
I think we use toothpaste because it kills the germs that can be in the teeth.
Okay, that is good. Annabelle?
I think we use toothpaste because the components in toothpaste aren't so like acidic, and therefore they don't really harm our gums and teeth.
Okay, all those are good answers. Thank you. Much as all those are beautiful answers, I expected us to align our answers to what we are looking at. And I think Annabelle tried to do that. There is a hand I'm seeing up.
Toothpaste removes the plaque and bacteria from our teeth.
Okay, thank you. There is this person here on the iPhone. I'm trying to look for the name, but I can't see the name. It's just dash dash. Okay, good luck.
I think we use toothpaste because, as someone said it before, it is not that acidic. Like also, it does not contain a lot of alkaline because even soap does kill bacteria, but I think toothpaste is the best because it has less of those other things used in other materials.
Okay, thank you. So one conclusive thing here is toothpaste contains an alkali substance. And remember the bacteria in your teeth is acidic. So that means the bacteria in your teeth, which is acidic, will require something that is alkaline to neutralize it. You can understand I'm bringing in a new term now, to neutralize it. And of course, I know most of us watch movies, we read a lot of books. So when I'm saying something is neutral, that means it really has no effect, right? So that means at that point, the toothpaste contains an alkali substance which reacts with the acid in the bacteria that is found in your teeth. And when those two react, that means they will produce a neutral substance which helps your teeth remain clean but still have no effect on the medium in your mouth. Okay, so I'll request someone who hasn't said anything since this lesson began to define for us what a base, to read for us this statement, what a base is. Please make sure your hand is up if you've not said something since the lesson began, because we would love to hear your voice surely. Noeline?
A base is a substance that reacts with an acid to form salt and water only. Okay,
very good. So when I ask someone to read, I expect that even you where you are, you're reading, because every time you read something aloud, it remains with you for a very long time. So when I tell someone to read, make sure you're also reading where you are, but your microphone should be muted if I haven't chosen you reading to avoid disorganization. So a base is a substance that reacts with an acid to form a salt and water only. So we've already understood what an acid is. So when this acid reacts with these bases that we are going to look at, we expect that they will form salt and water only. And in this case, it's not only the salt that we know, which we use at home. This time we are going to get a definition for what a salt is. And of course, that will be our next topic in case the coverage allows us to. So when we are looking at this, I have an example that I wrote here. So we have a base plus an acid reacting to give us salt and water only. This is more like an equation. When we have an equation, we have the reactants and we have the products. So the reactants in this case are the base plus acid to give us salt plus water. The hands that are up, is it that we have questions or we forgot them up? Because if there are questions, we can take them. iPhone, are you okay? Or you just forgot your hand up? Okay, anyways, let's continue. Okay, so now, like I said, we need to identify what substance it is. Is it an acid or a base or an alkali? Apart from testing and feeding, because like I said, I don't expect to find in the lab busy testing sodium hydroxide, busy testing drinking hydrochloric acid because you want to know if it is sour. So what other ways can we actually use to find out what that substance is? And for example, like the cars, the motorcycles have indicators. So these are things that communicate to you if you're on the road, because most of you at least have moved on the road or you have traveled by bus, by taxi, by personal cars of your parents or friends. So if you have interacted with some of these, at least you know that someone can show something to communicate to another road user that this is what I'm going to do. So let us suggest some of these indicators of the cars and motorcycles and their importance. Not the chemistry indicators. I want to hear from us, car indicators and motorcycle indicators and what those indicators do. For example, when you're on the road and someone puts on a specific light, what can you say that that light is trying to tell you as a road user? Hey, people, you've not seen indicators. Yes, Bernice.
And when they put on the left indicator, it means that they are trying to show you that they want to turn left.
Okay, that is very beautiful. Any other? Thank you.
Litmus paper.
But we've said not chemistry indicators, really? Okay, let's hear from DR, okay?
Like when the double indicators are on, it means the car has a problem.
Okay, when the double indicators are on, it means the car has a problem. Okay, thank you. Infinix? Okay, Infinix doesn't know that his phone is Infinix. Elaine? Elaine, your mic is muted. Please unmute.
Actually, when it shows the right indicator, the driver is going to turn right.
Okay, that is good. Cuts? Okay, in the chat, I'm seeing brake lights to show that the person is going to slow down. That is good. Mary?
Teacher, that was my answer.
Oh, okay. I didn't hear Kat's answer. I don't know if he unmuted and said something. I didn't see. Okay, so I wrote down some few of those lights, and they are, of course, we have the brake lights, the headlights, reversing lights, hazard warning lights. All those communicate differently that maybe I'm turning right. Please, Mary, can you please keep your mic muted, please? So when you're looking at the brake lights, of course, when someone steps on the brake, you will realize that those brake lights will show and they will communicate to whoever is on the road that this is what is going to happen. Then the headlights, the reversing lights, the hazard lights, the different indicators. Mary, we are going to chase you out of our class if you can't really follow our instructions. Okay, so what is an indicator in chemistry? Who has an idea on what we can say an indicator is? Or even examples of those indicators, you can tell us. Yes, Ada?
I think an indicator is like, for example, in an experiment, when you're carrying out an experiment, then you want to know, let's say, if this chemical is present in a substance, let's say it will change color, or basically an indicator is something that happens to show you a sign of anything, like, yeah.
Okay, thank you. That is good trial. Yes, Annabelle?
I think an substance that
that's the presence.
certain.
Phoenix, if you want to talk, please raise your hand. Yes, Annabelle.
I think an indicator is a substance that can be used to determine the presence of some chemical in an experiment.
Okay, thank you. That is good. Any other? Yes, Nora.
An indicator is a substance that changes color when it is added to an acid or an alkali.
Okay, good. Jasmine. Okay, so bottom line, really, an indicator in chemistry, you're using it to identify whether a substance is alkaline or acidic. So you're basically helping someone to find out. And of course, like we've seen, when you're looking at the indicators on cars, there is a color that those lights show that shows you that this is going to happen. So it's the same thing with the indicator. It's going to give you different colors depending on what atmosphere it's in, whether in an acid or in an alkaline. So this brings me to the most interesting part. So we are all going to make our own indicator. And in our next lesson, I'll give some of us a time, just a few minutes at the beginning of the lesson to explain to us how you made your indicator. You can even make a PowerPoint presentation and you tell us how you are able to make your own indicator. Of course, some of the instructions are here for those that don't have phones that take screenshots.
Teacher, could you please take on to the previous slide?
Yeah, I'm going to take back. I just wanted to show something here briefly. Okay, so you're going to take a picture of the previous slide and this slide, and you're going to use this information to make your own what? Indicator. And please use available resources. Don't go asking your parents for things which are exaggerated. Eh? So use available resources to obtain these things. So of course, when we are making indicator, we need to use, first of all, colored substances. For example, red or purple cabbage, you can use red bone villi, and then hibiscus flower or morning glory. So when you're using hibiscus, don't use the white hibiscus, use the red hibiscus. And then for morning glory, you can use the purple or blue. Is it blue or purple? So you can use some of those flowers. And I know most of us are internet literate. So you can look at those flowers so that by the time you go looking for them, you know what to do already. Those who are farmers, you can get from your garden a red or purple cabbage if you have it. And you can follow the steps on the next slide. So please, if you'll have prepared the presentation, you can inbox Mr. Kaziva and you let him know so that he can let me know so that we can create time for you to present before the next, in the next lesson. So you have a whole week up to Monday, really you should do something. Have we finished taking a screenshot of this so that I can move to the next slide?
Yes, yes.
Okay, thank you.
Yes.
Okay, so please take a screenshot of this slide as well. So those who are writing at least, and please, if you can't access ethanol or propanol, don't force your parents to buy alcohol. Just use warm water. You can just warm the water a little and then you use it to also bring out a very good indicator. So don't be there saying for you want ethanol and you really pester your parents. So just use available resources because it's important for you to learn how to use the resources that are available within your environment. Okay, so the WhatsApp link was posted in the group, in the chat. So please, if you're not on the WhatsApp group, make sure you connect on that link, and then you're able to get to the group, because at least the recording will be posted there. Invite your friends to also watch those videos so that they can learn. They can subscribe to the video and watch it as well. It will help them learn better. Even you, after watching, you can actually post it on your groups, on your status, and ask people to watch and learn in all the subjects that we are studying, really, because I think it will really help them to grow. Yes, Safra?
Teacher, I wanted to ask a question about acid here on ethanic acid. Like for it had two H's. Is it because hydrogen and ethanol both have hydrogen in them?
Yeah, so when you look at the ethanoate ions, and that's a beautiful question. When you're looking at the at this, and it's giving you hydrogen ions. Why we have these reversible ions? Because remember, we said it produces hydrogen ions as the only positively charged ions. But remember, there are some hydrogens that have remained here. So that means in this case, some of the hydrogens were able to be released as hydrogen ions, while the others remained within the what? Within the negative part of the what? Of the ions. So that is why we have these double arrows here, because part of the hydrogen ions were not able to ionize completely. And like I said, I'll request us when we get to that point to come up with these different ideas. That's why I didn't go deep into it. But I don't know if at least now I have helped to really clear the light.
Thank you.
Okay, you're welcome. So we'll stop here today, and we'll have our next lesson on Monday, but please kindly, if you're able to present, you can text Mr. Kaziba so that I can plan for it. You tell him to let me know. So, yes, but please, it will be good if we have at least several of us coming up with presentations. You can even store your indicator and you turn on your video and you show us those different extracts, and it's a beautiful experiment. You will really enjoy it. The different colors changing. You can prepare your soap. You may not even need to prepare a liquid soap. I'll leave that to us. You can use the soap that you have at home and test using your indicator, and then you say, hey, what substance is soap, depending. And of course, I know we'll have a great lesson on Monday. Okay, I hope we're able to learn something, and please do the work.
Excuse me, teacher, can you please send it to the WhatsApp group?
The what?
Bye, teacher.
To send the what?
The
No,
work.
I'm asking which work? This one. Oh, okay, that's okay. I can cut off these slides where we stopped, and then we can share it.
Excuse me, ma'am.
Yes, please.
Also at the WhatsApp group, could you also send a recording?
Yes, the recording will be posted today evening.
Okay, thank you.
All right. Okay, thank you so much for being an active class. Bye, and see you on Monday. Have a lovely week.
Yes, bye, teacher.
Bye.
Bye, teacher.
Bye.
Thank you.
Thanks.
You're welcome. Thank you too.
Bye-bye.
Bye-bye.
Thank you,
Bye.
teacher.
Clarissa.
You're welcome.
Excuse me, teacher.
Yes.